Okay, you're good.
What's this? Oh, I'm not logged in this one. One second. Hold on, I have it in the other window. Okay, so can everyone see my screen? Yeah.
Yes, I can.
Yeah. So so basically, last time we were exploring how we can put together a custom chatbot, right? So and then we took a look at some details of how ChatGPT itself is implemented in terms of behavior, and then looking at the tools that we have available, like especially in Python, how we can start to re-implement those features, like just using Python and the web, right? So conceptually, what I want to convey is several concepts that come together in order to create a good chatbot experience. So the first concept is that resources on the server side, on the side of the LLM provider, right? Whether it's ChatGPT, whether it's OpenAI or any other LLM, server-side processing for AI is very expensive and it's very resource intensive. For that reason, any requests we make to an LLM is never gonna be as fast as what we are used to when we browse the internet. You know, so in order to hide that fact, instead of processing the whole response and send it back to the user at once, they stream it, which makes sense if you think about it. Like, for example, there's a huge factory that has like a lot of inventory. It's not possible to just grab the whole inventory all at once. You know, there has to be trucks that make several trips back and forth, you know, to load containers, like a few containers at the time, and then eventually empty the factory. So it's the same thing here. The resources are too intensive for it to the need of resources is too big for the provider to instantly generate the response. That way, they have to send it to us piecemeal. And moving away from the provider down to what we can actually do as programmers, we see that through Python generators, we kind of have like access to the same mechanism. So if you can see my screen, the generator in that case, you can think of it as the factory. It does work internally, and then whenever we need something shipped to a customer, we can yield, right? And inside the generator, we can yield as many times as we need to. You know. So, any question on that? Like, I think we saw it last time. Okay. So
no question.
Yeah, sure.
I would like. J'ai une question. J'ai dit, I'm going to say that in French. Maybe someone else cannot translate. So, ce que tu viens de dire là, c'est comme curl et puis, comment on appelle ça? Genre la commande curl et puis la commande wget. C'est ça, si je comprends bien. Pour faire le truc là, genre pour donner les informations, là, il n'a besoin que de comment on appelle ça? Il ne peut pas nous donner toutes les informations. Il ne peut pas nous télécharger genre, tous les sites web. Il va nous donner partie par partie.
Yep.
Okay.
Yeah. So Ashil was just asking if it's similar to the concept of like using the CLI tool like curl or wget. So wget is a tool to like download files off of the internet, like without using a web browser. So it's exactly the same concept. Like the file being downloaded might be large, like let's say a few gigabytes. That file is not just gonna appear on your local machine in a second, unless you have a very, very fast network, right? It's gonna come to your system one piece at a time. You know, sometimes in networking we hear about terms like packets, you know, like data packets. It's gonna come a piece at a time until the whole file is reassembled on your local machine. So it's exactly the same concept. So yeah.
So basically, what the takeaway here for us is that a generator, the keyword here for a generator is the yield keyword, right? So if we're able to like write a function with that yield within it, then essentially we are creating a generator, right?
Yes.
Okay.
Yes. So if you see this loop over here, the generator like makes the data that it's yielding available on demand, only on demand, right? So in this for loop, every time we go through the for loop, it's as if we are asking the generator, give us the next item that is in line. You know, so the first time when we grab the next item, we go ahead and print it. So the first time it's gonna print 1. The second time it's gonna print 2. Then the third time it's gonna print 3, and so on and so on. Okay. Right? And at any point in the generator, like if you look at I have a link to the documentation here, right? There's something called stop iteration. So stop iteration, basically, like if we yield that stop iteration from the generator, it's a way to tell the consumer that the item is out of stock, like there's no more. The whole inventory is gone. You know, that way it's gonna make that for loop stop.
Got it.
Yeah. So I have the link in here, so you can read the documentation. It's very interesting, and there's also, I suggest also looking for Python, like Pycon on YouTube, and Python, and then generators. There's a lot of interesting talks about that. Actually, I should find these talks and then put them in the chat. Okay, so this is the first concept. So now that we understand what generators are, we can. Okay, someone coming. So now that we understand what generators are, there's a slightly there's a related concept to the generators. It's the concept of I think the proper term is concurrency, right? So what do I mean by concurrency? Concurrency is the ability to, if you want, multitask, right? Because the factory might be like they might have like only a single location. Let's say, let's say this is one of the Amazon warehouses from which they serve, from which they ship, customer like purchases, right? They ship their items from a single location, right? Notice they don't just ship items to one customer a day. They have the ability to handle a very large number of customers all at the same time. You know, so with that whole deal about the like 1-day shipping, you know, it's because they have the ability to multitask to get things moving. So yeah, this is what this library, which is part of the Python standard library, allows us to do, right? So notice that I mentioned concurrently and not parallel. There's a nuance. Parallel will imply that everything is done exactly at the same time, right? And then concurrency, the process in charge of doing the concurrent work, like, is able to multitask. So it does a little bit of work here to get it moving, and then switches to something else, do a little bit of work over there, get it moving, and so on and so on. Like that. Any question on that? No? Okay. So, okay. So the reason why it's important in that context of a chatbot is because if you take the example of OpenAI, multiple people are chatting with the ChatGPT at the same time, right? If they will go, if they tried to handle all of those chat requests in parallel, they will never have enough resources to, you know, to provide a good service. The quality of service will go down. But instead, if they do their work concurrently, then they can handle multiple chat messages at the same time. It's similar to what we do, right? And a lot of people have WhatsApp. It's possible for us to entertain multiple conversations at the same time. So it's the exact same thing. From WhatsApp, we cannot just chat with 30 people at a time, but we can do one at a time and circle back. So the same idea here. Okay. So if there's no question on that, I can move on to the next concept. So once we have generators in Python and we know about concurrency through async await with the async IO library, these two show themselves in this form when it comes to web applications. You know, so these ASGI and WSGI, those are web protocols, implementations of web protocols in Python, right? The first one, this one, WSGI, it's the older one. This one tries to do work in parallel. And for that very reason that I mentioned earlier, if the number of clients becomes large, the server will crash because there will not be enough resources to handle a large number of clients. But instead, if we use the ASGI protocol, the ASGI protocol is concurrent. And since it's concurrent, it allows, it provides the ability to handle a much larger number of clients. You know, and under the hood, this protocol here is leveraging both async IO and generators. Any question on that? Okay, so let's continue. So I have a small, let me see, did I skip something? So this is a small illustration, right? A request comes into the server, and then the server sends back the response, right? But through ASGI, there can be like a large number of clients for one server, you know. So the next concept is server-sent events. So server-sent events, you can think of it as the network equivalent of a generator. The same way that the generator is able to send data to the user of that data, like one piece at a time. On the network, like with HTTP, the equivalent is called server-sent events. So down inside the server, especially like it works with the WSGI or WSGI, but it's this implementation is limited. The ASGI is more appropriate for that. So inside the people say it as ASCII. Inside the ASCII server, buried inside the ASCII server, there will be a generator responsible for sending through the network like the same data, but like one piece at a time. And I'll try to like make a small illustration here. So let me see. So basically, the client will connect to the server. The server will respond saying that it has data for the client, but the data is going to be streaming. And the way it does that, the way that the server will let the client know that there will be data, but streaming data, is by setting a HTTP header like this one. So once the client receives that successful response together with that header, then the client will understand that it should not hang up the phone, so to speak, right? So in that case, the client will understand that it should keep that connection to the server alive because there's data coming through the pipe. So at this point, you see where it says loop. At this point, on the server side, there will be a generator that will something that will loop over the generator, the one that's supposed to generate the response. It's going to loop, and then every time it yields, some data will come to the client. So you can see some of the data that streams back to the client. And also, one interesting thing during the streaming back to the client is that the pieces of data that are sent back to the client, they do not have to be the same. So imagine the Amazon center has to ship the goods back to the customers, right? They're not gonna just ship I don't know, shoes. They might also, while they are shipping shoes, they might also ship, I don't know, gym equipment, laundry detergent, stuff like that. So.
Actually, do you mind talking a little bit more about that? So when you say it doesn't have to be the same, are you talking about, I hear you, are you talking about like data type, or are you so let's take the example like a text example, right?
Yeah.
When it's responding, you say it doesn't have to be the same. Like, can you talk a little more about that?
Yeah. So okay, so in concrete terms, right? So if we look at here, it's streaming data back to the clients, but here we see that it's sending in the first packet, it's sending user ID and the status of the user, which is active, right? And then in another packet, it's sending some information about a chat. Maybe it's a WhatsApp message or something, right? Typically, in a regular HTTP request, that are different than a server send event, you usually request something specific, and then you get that exact thing.
Right.
You know, I don't know what example. Yeah, let's say it's a server for an online retailer, and they want to send to the browser like the availability of the inventory for TVs, right? The request goes to their server. When it comes back exactly with that data. If they want, if the web application wants something else, it has to request it again with a completely different request and then get that. Whereas here, the browser connects to the server, and then it can be any data coming back. It can be data about the availability of TVs, and then client zip codes, and then I don't know, some random. Right.
Yeah. So even without asking for it?
No, I mean, there is some prior knowledge, right? Basically, I mean, it's not shown here, but in the data being streamed back to the client, there's an additional piece of metadata that is attached. So in addition to data, there's also an event name. You know, so it will be the label on the box. The box will say this is a box containing shoes, and then this other box contains kitchen utensils, and so on and so on. And then when the client receives that, the client only has to handle the box that it's looking for. The other one will be ignored.
I see. Okay.
You know, like people send you junk mail, right?
Right.
But through the junk mail, there's some mail that you actually want. The rest you just discard. It's the same thing.
And the benefit of that is speed, I suppose, or convenience, or is that just the way this protocol works?
It's the way this protocol works.
Okay.
And there's a speed advantage with the fact that once the connection is established, it stays open until there's no more data, and then it's closed.
Okay.
You know, whereas for regular requests, as soon as the response comes back, the connection closes. And then if the client wants something else, they have to call back. And then call back again. And there's a little bit of overhead to establish a new connection every time. So.
Okay. So it's like a call it's like a 24-hour call that never hangs up until you decide to hang up. And you can always, you know, you go back to the call, or you unmute yourself if you need something. Otherwise, you can mute yourself and just kind of.
Actually, if you go to websites like news agencies or live sports, sometimes you see the website has like I don't know, notifications coming in. Or even on your phone, someone sends you a text and then you get a notification, right? It's because they are using a similar protocol to server send events, while your phone connects to the server and then listens for notifications. So if you get a WhatsApp, it's gonna pop up. If you get something like an email, it's gonna pop up. But both the notifications of your email and WhatsApp and anything else, they come through the same pipe.
Okay, I see. Okay.
Yeah, it's kind of like that. Yeah. Any more questions on that? Okay. So we talked about streaming. We talked about concurrency, and we talked about like the data packets right through the server sent events. If you think again about the experience of using one of those chatbots, whether it's ChatGPT or any others. The reason why this protocol is interesting is because you can request several things, right? The chatbot can respond in a number of ways. It can respond with text. It can respond with rich text, text that has like some formatting or specific colors, like source code, for example. It can also be images. It can be videos. It can be a lot of different things, right? So through this mechanism, the chatbots can respond and label the data packet that comes in to say that, okay, this piece of data is an image, or this other piece of data is an audio file, or this piece of data is text, and so on and so on, right? And then when the client receives it, the client then decides how to best present it to the user, right? Behind the scenes, the chatbot like ChatGPT will do a lot of work. It will do some work in the background to, let's say, generate an image. And while the image is being generated, it's gonna go talk to another piece of AI to generate the let's say the description of the image, and then it's gonna go do some other work over there, and then as soon as one piece of background work is complete, it ships it back to the client through the pipe that's already open. That's why sometimes when you go to ChatGPT, I don't know if you noticed it, but at times, depending on your request, you might have like several cursors going at the same time. It doesn't always write from top to bottom. Sometimes it's writing something here, and then it's writing something else over there. And then, I don't know if you noticed, but yeah. Okay. So any more question on that? Okay, so here there's a small example. This one is just in HTML and then some JavaScript. So the concept is that this is the endpoint being invoked by this HTML page, right? So the request comes into this part, the event, and then right away it's gonna respond to say that this is a successful response. But client, just so you know, there's more data coming. And also keep the connection alive. So it does the exact same thing as this part here. And then once the client understands that it should not hang up, then the server can proceed with processing. So here, there's a function declaration. This one formats the data that will be sent to the client, kind of like this. And then this function here, set interval, it's a way in JavaScript to have something run into running a loop, right? So it runs in a loop in such a way that every second it calls this function called send event. So the client will receive hello world together with the current time every second, right? And then the client can display it somewhere like on the page for the user to see, right? And then this happens till the client disconnects, and then the generator gets shut down. Any question on that? Okay, so let's proceed So this example that we saw, it is using JavaScript and the Express.js library, right? JavaScript, similar to Python, they are both scripts. It also has the same facilities to run, to do some work in a concurrent manner, right? And it also has support for generators as well. So let's look at the one equivalent server for the Python world would be, for example, Fast API. So Fast API is using this web protocol here that we saw earlier, the ASCII, right? And let me see. And basically, this is the way to install it. I'll show you the code in a second. So basically, this one will help us to implement a server that's concurrent and that is able to do server-sent events. And then for presenting the information to the user, we can use this library here. It's another Python library that helps us basically generate web pages in a way that is very flexible. And okay, any questions so far? Okay, so if we pay attention to this block of code here in the JavaScript example, right? Like you can even try that in your browser, like or writing your own HTML file. This is supported by pretty much every browsers out there, right? This is the way that the browser understands how to establish a connection to an endpoint that is responsible for sending events, like the server-sent events, like we saw earlier, right? And to do that, that piece of JavaScript like has this class that takes in as that takes into its constructor like the location of where that endpoint is, so that it can start receiving data. And then you can kind of see like there's an event handler here. Every time a piece of data arrives, you know, in this case, it's able to create like a div and then add it to the page, right? But you can notice that this is kind of tedious, right? I don't think anybody here really wants to write that code, right? Or do you?
No.
Okay, so this is where this thing comes in. There's something called HTMX that basically does a lot of the common tasks that we usually do by hand by writing JavaScript for web pages, but it hides that from us. Instead, we can just focus, as long as we have it imported on the page, it helps us focus on just writing plain HTML, right? So what do we see here? We have an HTML div. I can decrypt this one for you. So this div, meaning that this HTML element is tagged with the ID Dogo SSE listener, right? This is an indication that this is the element that will be responsible for establishing the connection to the dog stream. So this part here is similar to this thing, right? But we don't have to write the JavaScript code, right? So it's going to connect to that endpoint for us, right? And then that connection is of type SSE for server-sent events. And then the way that we want to handle the messages we get back is specified here. So basically, HTMX with this syntax here instructs the web page that it should expect a package from the Amazon delivery, with the label terminate. It should also accept a package with the label dog breed no mass, and then another package labeled dog breed, right? So if any other packages show up, just ignore it. But if any of these three show up, then use them. Okay. Does it make sense so far? Okay, so let's continue. Yeah, go ahead. Okay, so let's continue. So what do we see? We see that we can easily notice that both dog breed and dog breed no mass are present on the page. So basically, what it does is that the content of the dog breed no mass will appear here inside this division, inside this div called dog breed no mass. And then when we have dog breed, it's gonna appear into this other div called dog breed. Easy enough, right? Okay, let's see it in action. So can you still see my screen?
Yep, you can see the code.
Okay, so let me run this one. This is the server part of the dog breeder application, and it's leveraging the fast API library that I showed earlier, together with Jinja. So we can see the same HTML I was just showing, with no mass, dog breed, and all that, with the HTMX and all that, right? So this server, together with this Jinja page, is basically HTML. It's going to produce the page that's going to receive the dog breeds, right? So let's see. Let's run this one. Okay, so I'm going to open my network tab also so you can see. So this is the address. Okay, so as soon as the page opened, we see that a connection was established. So let me refresh, then click on dog breed. On the right side, you can see the server sent events streaming in, right? And then we can see that data is changing on this part. And then at some point, data over here will also change, right? Currently the dog breed no mass is responsible for displaying this message. And then the dog breed, just a simple one, is responsible for this part, right? So if you pay attention here, when it's done, it says no more, and then it's gonna resume. Any question on that?
Okay. Can you hear me?
Yes.
Okay. Is the default behavior, is it to replace the content or to append it? Because I know, like for instance, right now, every single dog breed is replaced by the next one.
Yep.
But what happens if we want to keep the content on the page and append the other ones?
That is an excellent question. We can definitely do that. I'll show you. Let me. Okay, let's stop the server for now. Okay, so this is the server code, right? And actually, I'll give you I'll quickly give you more context. So we saw this page. There's also another one that is important. It's this one. This one, basically the Ginger library, it's a way to help us quickly format HTML, from Python, right? So we can see the structure of the message, right? We have events and data. And in the browser, the event will be in the type column, and then the data will be on the data column, right? So it comes from here. So the data, this HTML, is the one we see on the right. And then the event is what we see on the left. So this one is used inside the code like this. So this function basically finds this partial HTML and then takes in the event information and the data to be displayed. It also takes some attributes. So the attributes are basically gonna be used to do what you are trying to do, like with your question through HTMX. So this is the if you want, the generator that sends the events to the client. So we see, for example, to indicate whether there's more dogs coming or not, we generate this piece of HTML and then we yield it, just like we saw, right? And then we tell it the ID of where it's supposed to go. It should go into the ID called dog breed nomas. And then there's this special thing here that comes from HTMX. So this ID is exactly what we saw here, ID. And then this special syntax here says that when you get to the client, when this is set to true, by default, it's gonna replace the contents of this div. So if there was something else in here, it will get wiped out, right? So that's the behavior we are currently observing. When the first dog breed comes in, a few moments later, when another one arrives, it overwrites the content of the div. And this comes from this behavior here. But we can change it because we are not limited in HTMX. There's a whole bunch of values for those things here. So we can try like with before and let me rerun it. Okay, so what do we see here? I changed it for the status. So we can see that the status is no longer being replaced, but it's being appended.
Oh, yeah. Oh, I see. This thing is really powerful. Yeah.
Yeah, actually, like if you look at I have some references to, actually, let me scroll down real quick. I can show you. I have some references here for HTMX, and there's also an online book which is free to read, right? But if you want to support the author of HTMX, you can definitely buy his book. And basically, this guy, to give you the quick story, notice that the way we are developing web apps today is extremely complicated, and there's a very high barrier to entry for newcomers, right? Just because the tools that we currently use, like the quote-unquote modern tools, they make a lot of assumptions, and they lead people to work from a very, very, very high level to the point that they don't even see the mechanics of the webs underneath, right? So HTMX and Hyperscripts, those are two of his libraries, are intended to bring us back to the web basics, you know, by hiding a lot of the complexity. It looks a bit magical, but if you read the documentation provided here, it's very, very clear and understandable. Plus, he really puts in an effort to explain the web mechanics in a very clear manner. You know, that way there's no confusion. You know, so the references are here, and we can.
Is that okay? Cool.
So he explains everything. Like, what was the name of this thing again? Like this one. If I search this one on Google, so if I do HTMX and then this, so it will be, yeah, so it's very well documented. I'm just using the default, but there's also other values that we can pass it. And this specific one takes the same values as this one. So we have things like inner HTML. I think this is what's being done by default. No, inner HTML. No, I think inner HTML appends, if I'm not mistaken. Outer HTML replaces the whole HTML tag. And then the one that currently activated is before end. So we can see that before end means insert the response after the last child of the target element. So basically appending, right? And yeah, so you can go through. It's very well documented. So
okay, yeah, I'm on the page right now.
Say again?
No, I say I'm on the page right now. The book.
Oh yeah.
Find it. Okay.
Yeah, I mean, if you're curious about how the web works, the guy did a very good job, like explaining. So
in that book, in that HTMX book.
Yes, okay. And also the design hypermedia systems. This book.
Okay.
You know, so you can see the full table, and it's very well documented, and he has like some very simple walkthroughs. If I'm not mistaken, I think he's using Flask, which is a Python library for the server examples. And then the HTML is just simple HTML with those fancy like attributes. You know,
so it's not JavaScript based, right? It's just
no. HTML, you don't have to write JavaScript. That's the beauty of it.
Okay.
that's the whole point. You don't have to write JavaScript if you don't want to. The only JavaScript related thing is this thing here at the top. You put that, then that's it. You set. You don't have to touch JavaScript after that.
Okay.
Yeah, that was my next question. I wanted to know if it was possible to replace things like React and like the front end part, view and stuff like that with HTMX.
Yes, if you want, like one day I'll probably do a meetup just on HTMX because there's a lot of things in there, and it can definitely replace React for a lot of use cases. Not 100%, but most of the things that we use React for, it can easily be done with HTMX.
Okay.
You know,
I'm looking for, if we can do it like a meetup on that would be fantastic.
Yeah, I can do that. Because in reality, all these fancy JavaScript tools, like not everyone needs it, but unfortunately, this is what's being presented first. You know, people start learning web development with React, even though it's like they don't need it. You know, so
yeah.
Anyway, I'll digress. Let's get back to this thing. Yeah, so you can see that since we started to append, we have the no more, and then we have more, and then it keeps switching like that, right? So also notice there's a problem. Every time, because we don't have an infinite number of dog breeds, right? Would you agree?
Yes, definitely.
Right? So how come the string of dogs never end?
Does it loop or something?
Let me restart the server. So if you see, like, I think when it gets to W, it ends. So let's see it happen. Says more dogs, more dogs. Then at some point it's gonna say no more dogs. Actually, let me get this. So if you look here, this request will complete. For now, you can see the amount of kilobytes being sent, right? And once it says no more, it's gonna open a new connection.
So is the connection is the loop, right? Not the data itself. Is that how?
Yeah, so you see, another connection was open.
Okay, I see.
Right? So
okay.
who has a good explanation for that?
I really don't.
This one took me a week to figure out how to like address it. So basically, this protocol, the way it's implemented in the browser, it's not really meant to be shut down. It's possible to open it, but they don't give you a way to say it's enough. You know, it's as if you are at one of those buffets or like those friends, and then the moms just keep sending food even when you are full. It's kind of like that. There's no good way to say enough, right? And for that reason, I mean, when I say there's no good way to say enough, especially there's no good way, especially if you do not want to write JavaScript. If you write JavaScript, you might find some tricks to shut it down. But in this case, we don't want to write JavaScript, right? So how do we do it? So let's get back to, let me move this one on the side. So let's get back up to go. Okay, so looking at this template, right? The first thing we saw is that this Doggo SSE listener, this is the one responsible for establishing that connection to the server to receive the event. So the best way I've found to shut it down is what? Is to get rid of this thing. Get rid of it. Simply that. Does it make sense?
How do you get rid of it?
Yeah, exactly. So we get rid of it using the exact same what is that page? I think I closed it. We get rid of it using this same thing, this guy, because we know that this guy can update the DOM, right? Update the HTML on the browser. And we notice that there are several things that we can tell it. The default is outer HTML, right? So the default is true, which is outer HTML. And we can see that for now, we only leverage these two, right? And then we notice also that the event name corresponds to the ID of the HTML element that we want to replace, right? So what happens if we send this to the client? So this one, as the name implies, is the event that's gonna be responsible for removing this guy. So let's see how this happens. So let me shut down the server, go back to the code. Let me explain so it's easier to read. Okay, so we are inside the generator. So we saw that this one is responsible for status. This one is responsible for the dog breed. they are both using the true or before end, right? And then they also take in as attribute the ID of the HTML element to modify, right? So I commented out this code over here. So let me uncomment that. And what do we see? In this part, if you notice the indentation, it's this one. So after this indentation, basically this for loop is done, right? So after the for loop is done running, we come down here to produce this this HTML fragment, this time with the terminate, and then we don't really put any data. And then the key part is this. The ID has changed. This time we want to target the Dogo SSE listener, which is what? Which is this guy. The same one responsible for establishing the connections and then dispatching the events received. Does it make sense?
It does. But if you refresh your page, it's gonna resume, right?
Yes.
Okay. Just want to make sure.
Yes. So let's see it happen. So if I come back here, refresh the page. So this time let's observe. It's gonna do this. It's gonna do this until it gets to W. Let's see those events coming. At some point, we're gonna see terminate showing up here. Okay, almost done. See this? No more Dogo senior, and it stops. What's the last event? Terminate. So let's look at the actual HTML to see what it looks like. What do we see? We see the same Dogo listener, SSE listener, but whereas like its attributes are gone. Do you see that? Even though originally it was like this. With all these SSE connection, server sent events, event names. Now it's that. So it's disabled.
So that piece of code pretty much replaced that HTML tag.
Yes.
Yeah, that was really clever.
Yeah.
Man, this thing almost made me cry, man. Because like I will see people do it in JavaScript. I'm like, oh, this is easy. And then I'm like, no, I don't want to write JavaScript. Like, so I wanted circles and circles. I was like, this is crazy. But yeah, that's as simple as that. That way it shuts it down clean. So anyway, so that's that for this part. Okay, so let's move on. So we can all agree that this UI looks kind of crappy, right? ChatGPT looks nothing like it, right?
Yeah, that's true.
Okay, so in the interest of time, let me speed up a little bit. I have another demo here. It's not 100% complete, but where is the server? It's this one. So let's start this one. Let's see. Okay, so I have it running on the same URL. So let's refresh. Hey, now what do we see? Now we have pictures, we have forms, you know, we have some sample activity, you know. I even have like a trademark custom chatbot powered by your API key. Okay, let's see. You want to search for something? I have some examples here. Yeah, see, I was so mad about Equatorial New Guinea.
We just continue to find Equatorial Guinea.
They give me some interesting facts about that country, because I heard nothing good about them since they beat us. Let's see what happens.
It's pretty fast.
Yeah, because for the dog demo from earlier, I added some arbitrary like timeouts. Well, this one it comes as fast as what OpenAI serves.
It's really, really, really fast.
Okay, so this is one example. Let's do another one. I'll do another one in a different tab. Okay. Okay, so I think I had this query here for other languages that have support for generators. So I'm asking about Python, JavaScript, Lua, PHP. They are all scripts, so they kind of like all work the same. So let's see. Also, when you're looking at it, try to like notice some details, like, and let me know what jumps out to you. Oh, this one was short. Let me see. I think I had another one. Okay, let me see what you have. Like, well, from the previous demo to this one, did anything like jump out to you?
You have like pieces of code, maybe.
Yeah, but that comes from the query. Right? What about this one? Okay, so one thing we can notice is that there's better rendering, right? The previous dog demo was just basically printing the text onto the HTML, whereas now in the response we can see that there's some level of styling and formatting of the response. Like we can see some bold text. We can see lines, lists with numbers, right? And let me rerun this one again. And you will see something. So if I rerun this one, okay, so look at this. When it starts to print the code, at first it's not formatted, and then all of a sudden it changes. Did you notice that? Okay, let's see this one. See, it changes. Now the PHP one. Right. Okay, so how does that happen? I'll describe to you another aspect of the user experience for like implementing a chatbot, which is that if you have some familiarity with what's called data wrangling for data science or any data tasks, right? Usually the problem is that there's data available, but it's not in the shape that we want, right? So for that reason, we have to like write queries, try to normalize the data, do joins, like fix the formatting of like text in specific like cells, and so on and so on, right? This type of work for data wrangling, this is on the way into this is for for pre-processing data that will be fed into some sort of model. It can be just a simple regression model for statistics and stuff. It can be for machine learning or even deep learning and LLMs and things like that, right? It turns out that the same thing happens on the way out, because the thing in the middle, like the model, doesn't operate on data that has the exact same shape as what us humans are used to, right? The model doesn't understand code formatting. It doesn't understand colors like that. It doesn't even understand how to format a paragraph or anything like that. The model itself only deals with numbers. That's it, right? So, yeah, you have a question? Yeah.
Well, maybe you're getting there. So I was gonna ask. So that means the formatting is done on the browser, right?
Yes, not in the browser, in our server.
In our server.
Yeah, because by the time it gets to the browser, like again, there's no JavaScript here. Oh, sure. Let me see. Right, there's no JavaScript here. It's just HTML. Right, so there's no code related to formatting anything here. The only thing we have is that same HTML from earlier, and then some CSS. That's it. But there's nothing in this HTML page. Actually, I can show it to you. Oh, here is rendered. So there's nothing in this HTML page that's responsible for taking the data, inspecting it, and say, oh, this part here looks like code. So let's put some syntax highlighting. This other part looks like a paragraph, so let's do this. There's no such thing here, right? So it means that by the time we get to the client is it should be in the format that's directly viewable by the end user, right? And the thing responsible for sending that nicely formatted output is the server we control, right? So we get the raw response from the LLM, and then we have to inspect it to do some data wrangling, basically. And basically, during that data wrangling step, we have to address any potential issue that will mess up the rendering. Right? So conceptually, right, things that we need to implement a proper chatbot, we have to be able to do work concurrently, so that it's more efficient. We don't have to use too much resources, and also concurrently means that we can stream through servers and events, so that upstream from our server, meaning at the LLM level, if the LLM is slow, it's fine, because as soon as the first piece of data is available to our server, we can quickly process it and streaming right away to the client. We don't have to wait. That way, it removes that illusion of slowness from the end user, because he gets to see something right away, right? So, and also the pieces of data that come to our server and then we have to process it. It can come in any shape, depending on what was requested of the LLM upstream, right? So if we inspect and we realize that this is an image, then we have to take the necessary steps to format that image so that it's viewable by the end user. If we inspect and we figure out that, oh, this looks like source code, then we can address it and render it properly, and so on and so on. Right? And through the server-sent events, we have that flexibility, like we were seeing earlier. what is this? We have that flexibility because the data packets, we can label them, with the proper event name so that it's rendered properly at the end user side. So, okay, so let's quickly inspect that HTML. So you can see that there's pretty much nothing. This block here is the image for the user, those SVGs. And I think the other one is for, wait, did I skip it? Oh, sorry. I think it's this one. So this SVG here is for rendering the user icon. The other one here is for rendering the AI icon. And the content of the message itself is in the paragraph, right? So it means that when we render the block for the AI response, we directly have the proper HTML tags to render the response in like using some rich format, right? And then this block here, this is our input box where we can type the message, like you see, message ChatGPT. Let me duplicate this one. Right. So this default page is exactly the one we see here. Any question on that? I'm gonna switch to break down the server now. No question on that. Okay. So let's look at the server for this. Okay. So let's see. So we have the index page. So the index page is this one, the index.ginger2 is the same one as this. It's the one depicted here. The fact that we are using Ginger2, we can, if you want, we can section different parts of the page and then assemble them the way that we need. Like for example, the response HTML from the AI is done by this AI message Ginger block. Like the code is below, right? And for sending the streams of information to the client, we format the event name and its data using this one. Oh no, sorry. I use it inside the server, and this one is the one that adds the div on the client responsible for establishing the SSE connection. So this is what it looks like. We saw this earlier. And so once we have these modules in hand, the server will give us a variable called messages. And then all we have to do is to look through those messages. And then if those messages have a sender called AI, we know that it's the response from the AI. And then we use the fragment, like this one, to render it. And instead, if it's user, we use this other fragment to render it, right? The SSE block, I'll show you how it's used. Any question on this one? Okay. So we just saw the index page, right? So this one will present the form and everything, right? And then it's gonna generate, if you want, a request ID. We can use that into like an improved implementation of this server, like later on. So the event ID is used to basically identify the chat sessions, so that when we submit the request to the LLM, it gets added to the URL. That way we can use it as an, if you want, as an identification of these messages being exchanged back and forth. Right. And so if you look at the actual ChatGPT, you will see that they also use a similar mechanism to be able to tell the different sessions you've had with the LLM. So you can even go back in history and look at your exchanges for with different topics, right? So they use a similar mechanism for that. So this is the index page. And also these default exchanges that we see at the top, it's because I just hard-coded them here and then pass them to the template. Okay. So I have this variable, I'm not using a database in this implementation for now. So I have this variable, which is a dictionary. This one is going to be responsible for holding the request from the user when we redirect to the OpenAI page. So this is the home page, and then the OpenAI page is this one. And then it takes in an ID, which is this one. So it's reflected in the URL. This ID is the request ID. Okay. So when we get the request ID, we use it to, let me see. Yeah, so we use it together with the user prompt. And so we use it together with the user prompt to populate this object here, this dictionary. And then we construct the messages list. So the messages list will have user, sender user, and then the content will be the text that we typed. And then the response from the LLM will have AI, and then the content, the first content will be empty. Right? So what this means is that when we send that first request, I don't know if you notice how it was empty at first. Let me do it again. So if I do send, you'll notice that at first the AI message is empty. Right? It comes from the fact that by default, this is empty. So now, if it's empty, how does it get populated later? Where does this page, how does this page establishes the connection back to the server in order to get the response streaming back to the user? So let's see how this happens. The way it happens is that we instantiate a dictionary, right? In this case, we call the listener OpenAI. Actually, let's inspect the page so we can show you. Okay, so let's do it again. Where is it? Okay, so we see this thing here, the ID was OpenAI, right? We can see it here. And then we can see that the thing that's responsible for streaming the data, in this case, it's already disabled because it got the response. Right, so let's look at a longer query. Oh, I'm fast enough. So you can see that right now it's there. And when it's complete, it's going to switch back to the terminated state. So pay attention to this part. Yeah. Did you notice how it changed? Yes? No?
It was quick. Yeah.
Well, let me see. Okay, maybe I can slow it down.
No, I mean that's fine. That's fine. But yeah, I saw it. Yeah.
Okay, let me do it one last time. It's gonna go quickly. So I'll put back the same query in here. Hit enter. And then if you follow my mouse, I'm just gonna open that part. So see OpenAI, and you can see the URL, which is the same as the one on top. You know, with the events, response, no mass, and yeah, and then it switched back to all be true.
True. Yeah.
Right. So right now it's in a disabled state, so it cannot stream anything else because there's nothing else. Right. So by default, we set up this configuration with the ID OpenAI, same as this one. We tell it the path, which is OpenAI stream / request ID. This path, we can see it in the network tab. So if I click on one and look at the headers, so we can see it's localhost 6543 / OpenAI stream / and then this ID. This ID is the same as this one. Right, so this URL is the URL of this page we're looking at, and then this URL is the URL of the events that we're just streaming. Okay, and now the topics. The topics is what we saw when looking at the elements. So if I do it here another time, we're gonna see these topics. Yeah, you can see the. Oh, that was quick this time. Why did it go so fast? Yeah, we can see the topics: response, no mass, and then terminate. Then it's gonna switch. Okay, so these topics come from here. So once we have this piece of configuration, we can use it in the template. So this time around, the index template is going to get the messages, which contain the new prompt and the empty response by default, together with the request ID. I mean, together with a new request ID, so that we can make another additional request after that. But we don't worry about this one. Most important, it contains this configuration here, right? So going back to the index page, where is it? So if we inspect it in more details, we can see that the same parameters that were passed, right? The same parameters that were passed, like messages, the messages are here. And then we have a for loop to display the user prompt and the LLM response. But before that, we have SSE config, which is this one. This is exactly the configuration we had. So how do we use it? This SSE stream, I mean, whenever the configuration is available, this SSE stream is basically a code, like an HTML fragment defined on top. Right. Defined on top. And it's defined into this file called sse.jinja2. So let's quickly look at it. Okay, it's a simple file. So don't worry about the macro definition. Just look at the div. If you look at the div, you can see that it looks pretty much the same as what we saw in the browser, because the ID. Let me open it on this. Yeah, let's switch this one. Okay, because the ID is basically the listener. The listener comes from this part. So the ID will be OpenAI. The path which is here. It will be the /OpenAI stream /request ID, right? And then the topics. This one, there's a shortcut in the Jinja template. Basically, when we get a Python list, we can join the list with a comma, right? So meaning that this list on the left will be comma separated in here. And that's what we saw in the browser. Right? So coming back to the index page, when the user makes the request and then the response comes in, the response is going to contain this configuration. Therefore, it's going to add the div responsible for establishing the connection back to the server and then stream the responses back to the client. Does it make sense for this part?
Yes.
I hope it's not too complicated. Okay. Okay, so this is what happens. And we mentioned a few times this streaming endpoint, right? So let's take a look at it. So skip down. See, for this tiny demos here, the code gets a little bit bigger. Okay, so this is the streaming endpoint. So the first thing we grab that request ID, right? So once we have the request ID in hand, we use it to invoke the run OpenAI function. At the last meetup, we already saw a similar function. It's pretty much the same. I tweaked it a little bit. So what does it do? When the request ID is in hand, it gets a hold of that request dictionary we saw earlier, which currently contains the user prompt. So we retrieve the user prompt back out of the request dictionary object so that we have it, and then we print. Okay, and then using this user prompt, we put together some messages that we're gonna use to invoke OpenAI this time, right? So the user prompt goes into the role user and then contains user prompt. But then notice this part over here. One reason why I'm able to format the output is because I make sure to request that OpenAI answers me back using Markdown, right? So I'll make it clear, please respond in Markdown only.
Okay.
Right? It's one trick.
Interesting.
So notice also here that I'm directly using the OpenAPI library. I mean, the OpenAI library. I'm not using any of these tools you hear about on the internet, especially things like LangChain, LabIndex, all this craziness, because they take the exact same approach for what's called modern web development. They right away hide everything into layers and layers and layers of code and libraries, to the point that everything is obfuscated unless you are an expert into it, right? So it hides a lot of stuff, and then it becomes magical and everybody is scared of it. They don't want to touch it. But my opinion, they are a little bit full of it because this thing is new for everyone, so they are not experts either. Everybody's trying to figure it out.
It's interesting because when ChatGPT responds to you, actually sometimes when it's very quick, you can actually see the markdown, and then it changes back to the actual code.
Yep.
I don't know if you know what I mean. Like when it's streaming the information on the screen, sometimes you can actually see the markdown.
Yep, and sometimes the formatting is even broken. Sometimes you request code, and then they send it to you. It's not formatted. You're like, hey, what is this?
Yeah.
Clean it up. Like,
Yep.
yeah, because even ChatGPT and OpenAI, they have the same challenge, right? It's not like they have better controls over the model. The model answers the way it wants to answer, right? And then they also struggle to find ways to force it to answer in the way that they want. You know, just like I'm doing here. This is a simple one, right?
Yeah.
If you look at the LangChain library and other libraries, they use more trickeries to get the response into the format that they want.
Right.
You know, but it's possible to do it by hand. We don't have to use that. We can, it's nice, but we don't have to.
Right.
Basically, the less layer you put between what you want to do and the actual thing you want to like control, the better it is in terms of understanding and flexibility. The more layers you put in, then you have to deal with the assumptions of other people. And their use case is not necessarily the same as yours. So yeah. So anyway.
And if someday the library is discontinued or something like that, you pretty much shit out of luck.
Yes, especially that's why one day I think I was giving a hard time to Aziz, like saying that if the guy that maintains some of the libraries he use, like get run over by a bus, it's game over.
You're screwed, man.
Screwed.
Actually, that's what Google does. Like going back, like just anecdotally, like Google does that to a lot of some of their tools. Like they'll support a tool for like years, and then all of a sudden they're like, "All right, we're done," and then they discontinue, and then you have to scramble.
That's scary, actually.
Yeah, especially if you're using it in production. You know, it can be very scary.
Yeah. That's. I mean, what's for sure is that regardless of what people do in open source, whether they continue to maintain something or not, things that are never going to change, or if they do, they will change like 50 years from now, are basically the protocols. Protocols meaning things like HTTP. Regardless of the programming language you choose to use, HTTP doesn't change. I think currently they are barely starting to roll out HTTP 3. So if you count the number of years since the web was first created, they are barely starting version 3, right? So knowing the protocols is important because they don't change really, right? And even when they do, the previous versions of the protocol still work. They don't just disappear, right? So knowing HTTP basically and understanding it basically allows you to work with remote APIs like the one provided by OpenAI, regardless of the language you use. Like even this library provided by OpenAI, right? They have a specification that anybody can go and read and roll their own. So it means that technically we don't even have to use this library. We can just use Python and issue calls to the API. It's documented, you know. So yeah, so knowing the protocols like allow us to work with remote systems like that. Also, it helps us build experiences in the web and so on and so on, because all of those things are made possible by the web standards. So knowing them is important. You know, how it's implemented into a given language is just an implementation detail. So, but anyway, I'll digress. So this is the trick that I'm using here to try to force it to answer me back in Markdown. So why Markdown? Everyone is familiar with Markdown, right?
I am not.
You're not familiar with Markdown?
No, I'm not. I just Googled it, but
Yeah, I have a link for the thing here and a small description. It's just a way to format text. So usually for formatting on the desktop, we are used to things like Excel, right? Where we can have some bold text, italic, underlined, things like that, right? So Markdown is a way to do it, but instead of having to use the contextual menu of Word to say that, okay, format this paragraph this way, change the fonts that way, we can directly write plain text. Like when I say plain text, if you use Notepad or anything like that, it's sufficient. So you write it plainly, and then there's an agreed format for how to write it plainly. So as long as you follow the recommendations of whoever, like this guy that invented this format, then you get to have interesting things. So this is a visual description of what happens, right? When OpenAI answers us with Markdown, we can pass this Markdown file or text, we can pass it to a Markdown processor, right? So the Markdown processor will inspect the way the text was formatted and then generate the equivalent HTML. And we saw things like this, right? Blocks of code, and then paragraphs. And what was the other one? Lists and like bold text and so on and so on. All of those things are specified into the Markdown format, right? So, so the LLM is a large language model, right? So if there's anything it's good at dealing with text, any type of text or any types of characters, right? So Markdown, it understands Markdown perfectly. So forcing it to answer us with Markdown directly allows us to use some additional processors in the pipeline, so that by the time we generate the final output, it's in the format that is acceptable to the end user when it arrives in the browser. Right?
That MD file, the Markdown file, is actually, okay, let me step back. It's not really giving us a Markdown file. It's giving us a text with the Markdown, and then generates the HTML based on that. So we don't really see anywhere the Markdown.
Yeah. So we can see some examples. Like I have some links, like I said, in the thing, so we can see what it looks like. What's a good? Oh, maybe let me zoom in here. Yeah, are you able to see this? Okay. Yeah. So if you're able to see it, you can see when there's only one pound sign and then space and then a word, it gets rendered as a header. So see Dillinger on the right. This weird syntax here, it's a way to tell it to show an image. So the URL to that image is specified together with the text inside of it. Right? And then it gets rendered like this, build passing. Then we have Dillinger, blah, 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 cloud enable, like we can see it. It's a paragraph. And then the fact that it skipped like a line and then started adding like dashes and then sentences, right? This is a list. The Markdown processor will understand that and then render it that way in HTML.
So Ben, what we're saying is that ChatGPT will will result in the code on the left, right? And then once we pass it through the processor,
Yep.
we get the format on the right.
Yes, exactly.
Okay.
Exactly. So it's a way for the LLM to answer to us in a more structured way. You know, so when it's more structured, since there are good conventions about like Markdown, it's a format, a specification. Then we have tools that already exist that can process it. So the examples are shown. I went from Markdown, the Markdown answer to HTML. But guess what? You can also go from Markdown to PDF and to a bunch of other stuff. We can even go from Markdown to images. You see these images here? I can show you the text for it. Let me open the different. I think it's this one.
So it's just like processing a JSON or XML file, right, into other file.
Yeah.
Other outputs.
Okay, so I have one here. Which one is this? This one is streaming request and response. So if I switch to the image, you see. So this image comes from this text. Right? The other one we saw. Yeah. The one we're seeing in the browser, like this one, is exactly this one. Right? So it's just text. So here, there's no need for any special tool for writing it. But yet, since it has a structure which is well known, it can get converted through some tools into something like this. So here I'm using the gist functionality in GitHub, right? In the rendering pipeline, GitHub takes this file, that's the whole presentation, right? It takes this file, which is just plain text, and then understands the structure for it, runs it through its own preprocessor, and then gives it back. It even adds these widgets here for zooming in and out, even though I did not code anything like that. So see, it even understands code blocks and things like that. So yeah, so those are headers, features that you can kind of see. That's pretty much how Markdown works.
It's a pretty cool tool, Markdown. Very powerful.
Yeah. So let's switch back to the code. Where was I? Okay. So here I mentioned Markdown, but for example, in my local editor here, the one I added to the GitHub gist, I'm not using Markdown, but I'm also using another plain text format. This one is called org mode, right? But it's just plain text in the same family as Markdown and stuff like that. And that's what gives me this thing, this presentation. So yeah, so I could have requested org mode. But the thing is, if I had requested org mode, the processor in use will not have been Markdown. It would have been org mode processor, right? If it was an image coming in the response, I would have had like a different type of processor to go from that raw image data to HTML, so I can run it in the browser. If it was, let's say, an audio file coming back out, I could take that raw audio file and then generate through a processor, generate like an audio player for the browser and add it to an HTML page, and then run it in the browser for the user, and so on and so on, right? And And this input coming from the left is coming straight from the LLM in our use case, right? So through server sent events, we can see that we can have a variety of events that are labeled differently. So that's exactly what I meant. If we get something coming back and we know that it's the type of markdown, because basically we requested it, then we know how to run it through a markdown processor, which is a post processor, right? It's on the other side of the data pipeline. Like some people fed data into the LLM model, right? And then the LLM is spitting out data back out. So the same data wrangling that went into the pre-processing for the LLM has to be done on the way out, exactly like that. Right? So, so if you listen to a lot of the discussions around all of those AI startups, right? You will notice that at times the investors mention the fact that there is no real moat, meaning that there's no good way for those AI companies to differentiate themselves or protect their businesses, right? The ones that really hold the power and the value are the ones creating the LLMs, like OpenAI and the other companies. But all the other companies that are leveraging these foundational models to create applications, they are downstream from that, right? And the way they implement their products is by basically getting the raw response from the LLM and then run it through a bunch of proprietary processors in order to create the experience that they want for their end users. Does it make sense?
Yeah, definitely.
So there's one cool one I started to use, like City AI. Like this one, it's a free app. There's a paid equivalent, but it's free. Well, you can use it to discover pretty much anything around you. So the use, at least one use case is that sometimes you might go to a new place, right? And then you want to go to a restaurant. So you go to your Google Maps and say, or Yelp, and say like, what are the restaurants around me? So those guys recreated a similar experience, but it's powered by LLMs. You know, I think by default they run GPT-4, but they also let you choose other ones when you have the paid version. You know, so all of these text that you see, all of the links, all of the images, all that, they come out from the LLM. And the reason why they are displayed this way is because they have a bunch of post processors. They have a bunch of processors on the way out to handle images and text and buttons and recommendations, all that.
Mhm.
So tomorrow, as long as you have the money to pay the LLM provider, you can compete with them. They can't stop you. There's nothing they have done here that we cannot do.
So for the processor, is there a particular library that has all the different processors, or there are different libraries per processor?
Yeah, I can show you the processors. There's nothing magic here. It's just plain code. Let's see. There's one of them. I wrote half of it. The other one, ChatGPT wrote part of it for me. So I was like, hey, yeah,
the intern.
Yeah, the intern. That's how we call it. So I asked the intern, hey, when the raw response comes, and then I want to show it on we show it on time, so I'm not gonna show you the broken version, but let me switch to this one. So when I was displaying the code, I mean the response at first, there was no structure. So this list that you saw and all that, it wasn't displaying like that. If you remember the dog example, and when it was saying that there's more dogs coming, all the text was just jumbled together, right? So that's exactly how the raw response was coming in, right? So I had to go back and tell you, hey, give me Markdown, because I know ChatGPT can help me write a function, a processor for Markdown. And it did. So then I started having responses that looked like that. I was like, okay, at least this is cool. I can read it, right? But you see, it's not perfect. Like this one, this is those are the characters for rendering headers in Markdown. You see, the processor is not perfect, so it skipped this one, right? So I have to do more like massaging in the processor to address it. So after this step, I run into the next problem. The problem was code, because in order to have like nice indentation, I had to do something like this. Like if you just look at the part I highlighted, in order to have indentation, when we type a document, right? Let's say you are in Word, you type a paragraph, you type in on the line. If you want to go to the next line, what do? You hit enter, right? If you want to go down 2 lines, you hit enter some more. Well, those line breaks or no line characters, they are actually represented in text, and the character, when I say text, they have characters equivalents in text files, and those characters for the new lines is this /n, right? So /n is only valid inside the plain text document. But in HTML does not respect the new line characters. So it will display everything on a single line. So if you have a 1,000 line document, everything is going to be in one line, one giant line. So in order to force it to go to the next line, I have to replace those new line characters with the equivalent for HTML, which is this, the break. And you can see that if we inspect this one, let's see which one. I think it's this one. Yeah, so you see these breaks? These breaks come exactly from this. If I don't add them, the whole thing is going to be jumbled up, right? So I'm saying that to mean that those processors, they are nothing special. We invent them as needed. It's a data wrangling task. We have a bunch of text that looks ugly. How do we make it pretty? We have to find out the causes for that make it look ugly and then address them, like adding new lines, right? So the second problem I ran into, this one took me a long time to figure out. Those line breaks ended up inside the code. And I'll show you what the problem is. The problem is the convention for HTML for rendering code is that there's this special tag here, pre. So I can show you what pre does. HTML pre. So if we go to the documentation, what does it say? Pre is an element that represents pre-formatted text. In other words, when the browser sees the pre tag, however the text inside the pre tag is formatted, it's not going to touch it. Meaning that if you have if you have manually added some break tags, these break tags are going to show up in the code. And when they show up in the code, they look kind of weird. You know, so to make it go away, I forgot how I did it. I had to use some other trick and replace it. Yeah, like this one. Yeah, so this is the code that's highlighted, right? I had to go and find the line breaks that are added and then replace them back with the no line characters. Right, so they go back to their original state, and then I send the original text into this other processor that knows how to highlight code and give us HTML. Right? And then it shows up like this. You know, and even this one was tricky. That's my second implementation. My first implementation, it was formatting the code, but the thing responsible for the colors that you see is a HTML style sheet, right? It was creating the style sheet separately, right? And it wasn't rendering as nicely, like there was no colors. So I had to go and then massage that original processor so that it adds the styling inline. You know, that's why for each element, like we see the async keyword, like this one over here. Where is it? Yeah, this one. You see, I'm saying this is font weight bold. I want bold text. And then this color, which is the kind of like green one. Right? So
did you pick that, or is it something that's done by the style sheet? Like, did you actually manually code those colors?
Not exactly. I'll reuse the library that knows how to do syntax highlighting, and then I'll force it to add it to the HTML tag directly.
Okay.
Instead of creating a separate style sheet. And then it did that.
Because that was going to be really tedious if you had to think about all this.
Yeah. Yeah. So imagine the guy that wrote this library for highlighting text. Yeah. So that's what I was trying to say. Like these AI companies that build these experiences, their only way to protect themselves is the fact that it's really tedious to create those processes.
Mm-hmm.
So if you have the stomach for it, you can do like Perplexity and get your 3 billion funding and whatnot. If you don't, you go work for the man.
That makes sense.
You know, but they're not really doing anything like magical. That's all they do. Okay. So, any question on that?
It's good stuff.
Yeah. So, and it's not even okay. Let's see where we are. I'm pretty much done with the presentation, but I'll show you where we are. So we talked about these. This I already showed it to you last time. This is the. Actually, you should be able to copy this whole thing here, install the libraries as mentioned above, and then you will have a CLI app written in Python to interact with ChatGPT. I think I already did the demo last time, so this is the code for it. The streaming dog breeds that we saw, this is the whole code for it, and the HTML is above. And then this last demo here that highlights text and everything, this is here. But it's not a complete chatbot because there are. I skipped some parts because it's a bit time consuming to implement it. I'll finish it eventually, but I ran out of time before the meeting. So there's more. So this is not the full list of what's left, but I'll add them later for another part of the third part of this of building custom chatbots. So coming up next, we're going to start looking at features of ChatGPT, like building a custom assistant. So when we hear on the internet, we hear things like RAG, like retrieval augmented generation. That's what it's about, right? And then we're going to add persistence. Persistence means that the exchanges, the back and forth messages between the user and the LLM have to be saved into a database. That way, the LLM can remember the context of the conversation. So
okay.
this, yeah. So this
question. The assistant API, is it the same as the agents that we've been hearing? Are the GPTs or not?
No, the agents are different.
Okay.
The agents, they are different in the sense that it's almost like instead of prompting them directly, where they just answer you, you give them a goal, right? And then the agent, like the name implies, the agent means that in a way it has agency, right? So that agent will then, once you give it a goal, will try to figure out based on the LLM and the tools that you give it. The tools could be things like how to search the internet, or how to call an API, or how to process Markdown, or how to run an email. Yeah, all these things, the agent by itself will figure out what's the combination of tools and actions to take, and then put together an answer for you. So you give it the goal, and then it's gonna try to match that goal given the tools that you provide. Whereas the assistant, it's similar to search. So it's a similar experience as this thing. It's similar to search. Instead of being like Google that gives you a link to click, it's gonna read the information from the search, based on the data or the context that you give it, and then come up with the best answer to answer your question. If you remember, like, I think there was, I can't remember if it was late last year, we implemented a custom GPT that can read a book for data visualization and then make recommendations on how to create good charts. That's one example. So that assistant that's similar to search, another term is RAG, retrieval augmented generation. But ChatGPT and OpenAI call theirs assistant because the part where they have to persist the information or the context, it happens on their server. Whereas if you persist that information somewhere else, people usually refer to it as RAG and stuff. But it's pretty much the same thing. So the persistence here, like I said, we already implemented it last time. So if I search for CLI, oops. What is it? CLI. Okay, read it now. Oh, here it is. So this one, you should be able to copy the whole thing into a Python file and just run it. It should work. And yeah, so basically, since we know how to do persistence, now we're gonna put persistence into that final demo that I've made. Because as of now, every time I make a request, the previous interactions just disappear. So it answers with no prior knowledge. So we can combine the persistence and the assistant feature. Assistant meaning that we can also give it things like books or images to add to the context of the exchange. So that's what I mean by assistant data. And then the answers from the LLM are uniquely identified, right? So we are part of the way there, but it has to be saved into a database. You know, that way we can keep the context of several exchanges going, right? So it means that one user can have several conversations with the LLM, and they are persistent. And then we can even go beyond so that several users can have several conversations with the same LLM. You know, that way, if we both, like, let's say, if all of us use that server implementation within our own accounts on the server, we can have our own threaded conversations, and they're not gonna overlap. So, and then there's one new thing that I found very interesting, but I haven't had time to add it to the demo today. It's called semantic router. So we've seen how the LLM can respond in a various number of ways, right? So how can we help the LLM to guide it better to what we want it to do? You know, so let's take a use case. Let's say we implement an assistant for learning statistics and data science, right? So thinking about it, some answers will be textual. Other answers might be illustrations, like graphs, right? So from our request to the LLM, how is the LLM supposed to know when it's supposed to provide an illustration or provide text or provide both? Right? That's where the semantic router comes in, because the semantic router basically will pass our prompt to figure out what the prompt is about. And then for the assistant, we're gonna have some routes that we previously created that will deal with specific types of requests. So we can have a route that leads the LLM to deal with images, and then some other routes that deal with guiding the LLM to produce text, you know. And then since it's gonna be like let's say a data science assistant, if we start to ask it about medicine, the semantic router will figure that out and say that, hey, this LLM, this assistant is only getting paid to do data science, not to train you to become a doctor or something like that. Does it make sense?
Yes.
Yeah, okay. Yeah, so this is gonna come next time, because that's like, it's a lot of work. We're gonna get there eventually. Yeah, but for the tools to use, I think we can pretty much stick with Python, a little bit of HTML, and then for the dynamic interactions in the browser, I think HTML can handle most of it, if not all of it. And yeah, and that's pretty much it for today.
Well, thanks. That was really good.
Yeah, thanks.
Yeah, that was very good, as usual. Thanks again for sharing all this knowledge with us.
Yeah, I'm learning at the same time. That's why I'm always
Yeah,
running
well,
late.
you learn very fast then.
I'm learning at the same time. So
Yeah, that's the thing about these talks, is that it forces you to learn, right? So
yeah.
well, Kofi, we'll connect. Do we have Kofi's email?
I'm not sure, but I can text it to the.
Yeah, if you can put it in the chat, I'll grab it, and then we can connect early next week if you're still interested in doing it. So the date would be what is it? February 10th. That would be February 10th.
Okay.
Yeah.
February 10th. A couple of weeks from now. Yeah.
Yep.
Yeah.
All right, I got it.
Yeah. Also, guys, I created the Discord. I think I mentioned it last time. I started to post a few things there, and I still have to finish that website. Oh my God. Let's see. Yeah. So if you come to the website, I think let me share the URL again.